Hi everybody, welcome back. So last time we got this awesome formula, which I'll zoom in as y hat, and this thing is a vector. Okay, I know I don't have a vector sign on it, but it's a vector. It's an ordered list of our predictions that is just the formula of the matrix multiplication of our design matrix and our parameter vector b, or beta. Okay, so that's great. We can get those things very easily. We can get those predictions quite easily, except we can't necessarily get good predictions from this. It's very dependent on the beta that we have. We need to find the beta vector that minimizes the MSE still. Okay, so the MSE is still going to be exactly the same thing. It's still, if I was to go back from it before, there's no real need to change this thing because it's still going to be the y. Forget about the notation that I'm comparing it to from earlier. It's just the predicted value minus the actual value squared, and then the average of all of those. Okay, so you sum all of the differences between your point and your line, your predicted and your actual, you square that, and then you sum all of those, and then you divide it by the number that we had. So that doesn't need to change in this new kind of idea of multiple linear regression. But what does need to change is how we figure out the beta vector that minimizes the MSE. Okay, and I say it's changing, but really it's actually the exact same thing, is just getting all of the derivatives and setting them equal to 0. But we think about it again as beta as this collection of stuff. Beta is a vector, okay? And so we don't really want to think about explicitly writing out partial MSE by partial beta naught and partial MSE by partial beta 1 and partial MSE by partial beta 1. You see it's getting, or sorry, by beta 2. It's getting annoying already. And so what we do instead, and I mean instead, but it's exactly the same thing, is just thinking about the derivative of the vector. Okay, and it's just the gradient, we call it, it's the vector of all of the derivatives with respect to those components. And so the gradient is really just the derivative of something, so the MSE. So I'm going to write the gradient of the MSE, and thinking about it as a function of, I can just write beta, really that means beta naught, beta 1, up until all of them. So the gradient of that with respect to the beta vector is just the component-wise thing of the partial derivatives of the function with respect to that particular beta component. And if this is confusing you, don't worry too much about it, but it is kind of important. So this first component is written as partial MSE by partial beta naught. Okay, so that's the first thing. Is remember, this is going to be the same dimension as beta because it's just replacing all of the beta slots, beta naught, beta 1, with their derivative of the MSE with respect to that component. Okay, so that's the first thing. The second thing is the derivative of MSE with respect to beta 1, and that is going to be, sorry about that, all the way down until partial MSE by partial beta p minus 1. So there's p minus, or so there's p things. And I'm sorry about that notation. Okay, so we get this vector, and then from that we can set that vector equal to the vector of zeros. Okay, and I know this is kind of weird, but if there's p things here, it would be 0, 0. Set that equal to all zeros where there's p of these things. Okay, so p dimensional still. If we set that equal to 0, that's the same thing as just setting the, if I was to write this explicitly, this is equal to setting the vector, I'll just say, this is saying partial MSE by partial beta naught is equal to 0. And partial MSE by partial beta 1 is equal to 0. Okay, it's setting them equal to 0. And that's the same thing as we were doing before. Okay, with this, if I could go back to this derivatives thing way over here, is we were just trying to set this thing equal to 0. Okay, this thing right here And we want to do that for all of the parameters. If we get the derivatives with respect to of the MSE, with respect to each of them, we set them all to 0. That is what's going to minimize the MSE. And again, if this was confusing, don't worry too much about what I just did, but it is at least useful to understand that this thing is the gradient vector. Okay, it's the gradient of a vector, which means for some function, which the one we're interested in is the MSE, all of our parameters, we just get the derivative of that function, and then each of those components is the derivative of that with respect to that component. Okay, and then we set those equal to 0, and then we do a bunch of crazy linear algebra that I'm not going to show you to get some formula, which I'll give intuition for coming up. So if you didn't catch too much about this video, don't worry too much about it. I hope you understand the idea of a gradient and setting it equal to 0. I will see you in the next video.